Hello everyone. So in the previous class we have discussed about the vector integration of part 1. So today we will discuss about the vector integration of part 2. If you like the vector integration part 1 or in the previous videos, if you like this, then please share it and comment if there are any mistake, and of course subscribe the channel and click the bell icon for the new videos. So today we will discuss about the vector integration part 2. So what this part 2 content? So we will discuss about the surface integral, then the volume integral, and the theorems. Okay, so today we will discuss these three topics: the surface integral, the volume integral, and the theorems. So what is the surface integral? So this is a 2D integral. So this is a 2D integral and we need a surface. We need a 2D surface. We need a 2D surface. That means the surface that it can be space, that is it can be three-dimensional, but we will integrate the integral of the vector field or the scalar field using over a 2D surface. So that surface, that 2D surface may be circle, may be parabola, or maybe your ellipse, hyperbola, etc. Okay, so we will integrate the vector field or the scalar field over these surfaces. So how we will represent the surface integral? So it can be represented as if it is a vector field is given to you, A is a vector field that will given to you. So we can calculate A vector dot ds vector, or the second one is your scalar field with the ds vector, and third one is the vector field plus product with the ds vector. So the main important thing is the ds vector. If it is a scalar quantity, then you can then this integral can. So this integral is a scalar, this integral is a vector, and this integral also vector. So this is also vector. So we have seen in the line integral also this three case. In surface integral this is also same three case, but the dot product will give you a scalar quantity, and the scalar field will give you a vector quantity, because this is the phi only. So you have to integrate over this ds. This is the vector, so ds is the vector, so we have to find what is the ds vector. So the important thing, it is the ds vector in the surface integral. So remember, this is a 2D integral, and we also need the limit also, a b c d, that is the boundary of the surface. So these are the three types of the surface integral. So the main important thing is how we will find the ds vector. Okay, so let's go to the ds vector. What is ds vector? So remember, we can write ds vector as, we can write the ds vector as n cap into dA. Okay, we can write n cap into dA, and n cap is the vector, n cap is the vector perpendicular to surface. Okay, so n cap is the vector that is perpendicular to the surface. Why we have written perpendicular to the surface? Because the normal of a surface is always perpendicular. That means if this is the surface, then the n cap is, that is the direction of the surface is outward, because it is 2D dimension, it is two-dimensional. So if it will rotate, then the perpendicular will give you the surface direction. So remember, the surface direction is always perpendicular to the surface. That means if you are taking the xy plane, then your n cap will be k cap. If you are taking yz plane, then your n cap will be I cap. Okay, so for the xy plane, I'm writing for xy plane, that is the surface. If the surface is in xy plane, then your n cap, sorry, your ds will be your ds will be k cap into dx dy. So this is my dA and this is the n cap. Then if it is yz plane, then your ds will be I cap dy dz. Then if it is xz plane, so similarly your ds will be j cap into ds dz. So remember, so these are the surface ds vector in Cartesian coordinate system. Okay, so we will see in the what happened in the rectangular coordinate system, in the polar coordinate system, in the curvilinear coordinate system. So this is the ds vector n cap into dA. Okay, so now the dA is the area element. Okay, so this is the area element. This is the area element. So this is my ds vector, that is the n cap into dA. So what is the dA? dA is your area element. Okay, so remember the n cap always perpendicular to the surface. So this is the ds vector. If the surface is in xy plane, then your n cap will be k cap. But there is another method also, because this is the plane actually. If the surface is xy plane, then your n cap is k cap. But the surface, if you will be circle, if it is hyperbola, it is parabola, it is ellipse, then we need the parameterization. Okay. For curvilinear coordinate system, okay, for curvilinear coordinate system we need the parameterization. We already discussed about the parameterization in the line integral class. So if you don't know about this, then go to the previous class. So this is that is the vector integration for part 1. So this is the parameterization for curvilinear coordinate system, that is your polar coordinate system, or your cylindrical coordinate system, or your spherical coordinate system. So on such case, you have to how you will find the n cap. So remember the n cap, the first formula, the n cap is h1 h2 into du dv. So for if you discuss the cylindrical coordinate system, sorry, this is not n cap, this is actually dA. So for cylindrical system, your dA equal to nothing but r dr d theta, where 0 to theta is your 2 pi. For spherical coordinate system, your dA can be r into dr d theta, or this can be r square sin theta into d theta d phi. Remember, so these are the area element. Okay, these are the area element. dA is equal to h1 h2 du dv. Okay, so this can be also h1 h3 du dw, or this can be h2 h3 dv dw. So these are the three cases in your cylindrical coordinate system, spherical coordinate system. So that can be h1 h2 du dv, or h1 h3 du dw, or h2 h3 dv dw, h2 h3 dv dw. So what is h1 h2 h3? So h1 h2 h3 is your scale factor, and uvw is the r theta phi coordinate system, or r phi j. Okay, so h1, if you are discussing the cylindrical coordinate system, for cylindrical coordinate system, your h1 is 1, and h2 is r, and h3 is 1. Similarly, for spherical coordinate system, so here u is r, v is theta, and w is z. So this is the curvilinear coordinate system. h1 is 1, h2 is r, and h3 is 1. So these are the area element dA. This is not n cap, this is dA. Okay, so these things we need for surface integral case. And then, so next, how we will find the n cap? What are the different formula for n cap? Remember, this is the area element for r d theta. If you remember here d r d theta, this that means r and theta are variable. But in the second case, in the spherical, we have a two area element. But in the second case, here r is not variable, r is constant, and r is the radius of the sphere. But what is the variable? Variable is theta and phi. So you have to remember the curved linear coordinate system to know about more this. H1, H2, H3 are the scale factor, and UV, are the parameters. UVW are the parameters for cylindrical and spherical coordinate system. For cylindrical, U is r, V is theta, and W is z. But in the spherical coordinate system, H1 is equal to 1. For spherical, if you see for spherical, here H1 is 1, H2 is r, and H3 is r sin theta. Okay, r sin theta. Here H1 is 1, H2 is r, and H3 is r sin theta, and U is r, V is theta, and W equal to phi. So these are the cylindrical coordinate system. In the spherical case, so this is cylindrical case, this is spherical case, and the main formula is the dA, H1 H2 du dV, or H2 H3 du dW, or H2 H3 dV dW. Okay, so this is U, this is U, du dW, du dW, dV dW. So this is the area element. So now we will find how we will find the n cap. For this parameterization, how we will find the n cap? So it is important how to find the n cap. So there are several formulas to find the n cap using the Jacobian also. So what is the first thing? If the surface is given, how to find n cap? How to find the n cap? If the surface is given, if the Cartesian surface is given, अगर आपको कार्टेशियन सरफेस दिया है तो वो सरफेस क्या होगा ना, z इक्वल टू f ऑफ x y. आपको इसी फॉर्म में लाना है. अगर f of x y z, if it is given f of x y z, that means say x square plus y square minus z equal to 4, then you can convert z equal to x square plus y square. That means one example I am giving you. If this is given x square plus y square minus z equal to 4, then what will be your z? Z will be x square plus y square minus 4. So make this surface, okay, this is not vector field, make the surface to in this form. Z is a function of xy, okay. So make to this form, so Z will be your f of xy into y. So if the surface is given in the Cartesian coordinate system, then what will be the answer for n cap, okay. What will be the answer for n cap? So for n cap, we need the partial derivative, that is the zx, that means del f by del x, then the zy, that is the del f by del y. So what is the my n vector? My n vector is nothing but minus fx, minus fy, and then 1. So this is the n vector. So your n cap will be minus fx, minus fy, 1 divided by 1 plus fx square plus fy square the root over, because this is the unit vector. So you have to find the n cap. Then what is the dA? What is the dA? Because when we are integrated a vector field, we need the ds. So what is the ds? The f vector dot n cap into dA. Okay. So this is the things, f vector dot n cap into dA. So your n cap is minus fx minus fy 1, then 1 plus fx square plus fy square into dA. Okay. So this is the important thing, so you have to remember. And remember your dA is, I have told you, for if it is the surface in the xy plane, so there will be some limit. If this is the surface plane, then there your for xy plane, your dA is what? Your dA is dx dy. Okay. Then if it is a yz plane, then that will be difference. So remember. But in this Cartesian coordinate system, what will be your dA? And your dA will be 1 plus fx square plus fy square root over into dx dy. Okay, so this is the dA and this is the n cap. So if you will multiply this, then you directly get this answer as a to b, c to d, f vector dot n vector into dx dy. So finally you will get this. But how will find the n vector? The n vector is minus fx minus fy 1. Okay, so first we discuss about that how we'll find dA if the plane is given. Okay, but this is not the plane, this is a surface. This is a generally surface, this is not a plane. Okay, so this can use for any surface z equal to sy. Remember, this is the surface. This is important. If this is given to you, then how do you will find the surface integral? This is the formula. Okay, so if it is given only xy plane, then your n cap will be k cap. If it is given yz plane, only yz plane, no surface, then your n cap will be yz plane, the n cap will be I cap. Okay, so this is different and the plane is different. This is any surface. That means that can be a circular surface, that can be a parabola surface. So if the surface is given in the form z equal to f of xy, there is three variable x, y and z. If xy is changing, then z also changing, then you can find the dA equal to this one. So finally the surface integral will be f vector dot n vector into dx dy. What is n vector? So this is n vector. Okay, so you will find this using the curvilinear coordinate system also. But the surface is z equal to f of xy. If it is only plane given, that means yz plane is given, then your n cap will be I cap. Okay, try to remember this. So this is difference from the plane that we have discussed in the started. So now we will go to the second formula, how we find the n cap. That is the second formula for finding the n cap. Okay. Okay, so the second one is, remember, the curvilinear system. For curvilinear system, that is for cylindrical and for spherical. For cylindrical and spherical, I already discussed, your dA is nothing but h1 h2 into du dv, or this is h1 h3 into du dw, or this is equal to h2 h3 into h2 h3 dv dw. Okay, so these are the area element for dA vector. Then how you will find the n cap, that is the n vector. So your n vector, remember, your n vector is nothing but this is okay, so ru plus rb vector, or this can be rb plus rw, or this can be ru plus rw. Okay, so what is given to you, then what is ru? In the curvilinear coordinate system, that is in the cylindrical or spherical coordinate system, you have to find r. How you will find the r? So that is different. So r will come in the form of uv, or r can be formed in the form of r theta. Okay, so look to the cylindrical coordinate system. In the cylindrical coordinate system, we have r vector equal to r cos theta, r sin theta, and then z. Okay, now in the spherical coordinate system, so this is r sin theta cos phi, and then r sin theta sin phi, then z equal to r cos theta. So these are the position transformation in the cylindrical and in the spherical. Okay, so this is cylindrical and this is spherical coordinate system. So these are the position coordinate system transformation in the cylindrical and in the spherical. So from this, I have written here uv, u is your r, b is your theta. This is for general, I have written uv. Okay, this uv can be your r theta, or this uv can be your r theta phi, or this uv can be your r phi. Okay, So that depend upon, so here u is your r and v is your theta. So you can also in the cylindrical coordinate system you can tell rz also, you can tell rz theta z also. So these are the two difference. Okay, because in the spherical coordinate system I told you from the past class that this is 2D integration. So, but because okay, so this is 2D integration, but in cylindrical we have three variable r, theta, z. So how we'll get the two variable? Make one constant. Okay, make one constant and then take the two variable. In the spherical case also, make the radius as a constant and take the theta phi variable. Then you will get the ruv. Okay, so in the first case, if it is cylindrical, then your z is a constant. If this is spherical, then your phi is a constant. But here in this case, theta phi, your r is a constant. But if you will take in the spherical coordinate system, so here also r constant. In cylindrical coordinate system, some are writing r as rho, and the theta phi also change phi to theta, so that does not matter. So remember, so here in this case, your theta is 0 to 2 pi, but in this case, your theta is 0 to pi, and the 0 and your phi is 0 to 2 pi. So how we will find the n cap? The n vector. So your n vector is ru cross rv. So this is important. But what is uv? I have written uv in general form. Okay, so uv can be r theta, uv can be theta phi, uv can be r phi. So in that case, your dA also change. If you are taking du dv, then your answer will be h1 h2 du dv. If you are taking h1 h3, then your dA also different. So this is n vector and this is dA vector. Okay. So how we will calculate the surface integral? So this is the more about the ruv, that is the position, and then how we will change the position transformation to uv. uv I am written in general form. So how we will integrate this? Suppose a vector integration is given to f vector, that n cap into dA, and that is equal to actually f dot ds will be given to you over a surface S. Then that can be also write as f vector dot n cap dA. But what is the n cap and what is the dA? So you can write this. Remember, if the f is given, remember f is given in terms of x, y, z, then you have to transfer it first. F of uv. Okay, so you have to first transfer it to f of uv. What is u and what is v? I have told you before 5 minutes. So f dot n cap dA. So transfer the fy x, y, z first to uv using the cylindrical or spherical coordinate system. Which coordinate system you are used, that is most important. If you are use the cylindrical coordinate system, then change x equal to r cos theta, y equal to r sin theta. So totally change. Okay, so this is given to you in the xy form, f of xy in dot ds. But when you are solving this, your answer will be in terms of uv, f should be uv. Then ru plus rv into du dv. So this is your formula for your curvilinear coordinate system. So change the view. So this is the limit of u and this is the limit of v. So a to u b and c to d. So this is the curvilinear coordinate system. So the very important is these things. This is the important. How you will find? Now change the f to u and v. Then find out the ru. What is ru? So your ru is nothing but del r vector divided by del u. Okay. So this is the partial derivative. Find the ru vector. How you will find the ru vector? Now this is del r vector divided by del u. How you find the r vector? Use the cylindrical and spherical coordinate system. Then you will find the r vector. Then take the partial derivative with respect to u. You will find the ru vector. Similarly, find the rv vector. Take the cross product. Then so this is the n vector. Then this vector will be given to you in the xy form. You change this xy form to uv and then dot product with the ru cross rv. Then your du dv. So du dv may be dr d theta, or your du dv may be d theta d phi, because I have changed the uv I have written in general form. Okay, so this is the curvilinear coordinate system, how you will change. Okay, so next we will go to the third part, that is Jacobian. First thing is change the variable. change variable. So how you will change? Now suppose this is given to you. This is a function of xy, function of x and y that will be given to you. So this is given phi of xy. So this is a function of x and y. That means that can be x square minus y square divided by x plus y, or this can be your x plus y by x minus y, or this can be square root of xy. So anything. So this is a function of xy that will be given to you. Then change the variable. So how you will change? Now you change u to a function of xy. Change. Okay. So remove this. First write that x change to the phi change. Okay. So change the phi of xy to another function of uv. What is u? Now u is a function of x and y, and the b is a function of x and y. Or you can write x as a function of, this is not derivative. Okay, write another function. X is a function of uv and y is a function of uv. You can choose either of one of them. That is, choose x transformation or uv transformation. So these are the two transformation, and how we will choose, this is depend upon the choice of phi. Okay, so look to your function how it is given. If it is given x plus y by x minus y, then I can take x plus y as u and x minus y as b, or x plus y as b and x minus y as u. So these are the choice depend upon the transformation. So this is the Jacobian use the surface integral over scalar field using the transformation. This is the transformation actually. Transform. Okay, we will transform one variable, or sometimes the Jacobian is called as the variable transformation technique. So this is also called as variable transformation technique to find out the 2D integration. But remember, this can be only used for a scalar field. Okay, for a scalar field. This technique we will use for a scalar field. So this is a scalar field given to you. Change the scalar field to uv, then you will get simplex. This is complicated. Though you change the transformation, then you will get the uv. Then the second thing, how we write the integral. So suppose this is the phi, and you have to give a surface integral. That means if the ds is given to you in a dx dy case, okay, and one limit is given to you, that is the surface s. So this is a function of xy, integrate over dx dy. This is also a two-dimensional surface integral, but there is no n cap. Okay, there is no n cap because phi is scalar. Since phi is scalar, we don't need n cap. This will be given to you in the question. This is a phi is a function of xy. Okay, phi is a function of xy. Then integrate over dx dy. Then how will we do this? So what is the technique? Now the phi is changed to uv. The phi is changed to uv. You have changed the phi to uv. So now you have to find the Jacobian. Take its mod, that is the positive Jacobian. Then du. Okay, so this is the formula. How you will change the transformation for a complicated question to simple one. So find out the Jacobian, change the variable. Then take the, if it is negative, take j as positive, because this is scalar integral, so that never will become negative. If n cap is negative, then negative will come. But here in the scalar case, you have to find out the Jacobian, take its magnitude, then change the transformation. That given phi, you have to change to f of uv, then take the Jacobian, then find out. Okay. So the important thing is how to find the Jacobian. How to find the Jacobian is important. So how we find Jacobian? So this is the variable transformation. So we change the variable. That means we change the variable xy to uv. Okay, we change the variable to xy to uv. Then what is your Jacobian? So you have to use the Jacobian as uv divided by xy. सो ये जो है ये नोटिफिकेशन है हाउ यू राइट सो u comma v divided by x comma y. Okay, so these are the comma x comma y, u comma v. How the Jacobian will find? Take the determinant, take the partial derivative del u by del x, then del u by del y, then del v by del x, then del v by del y. Okay, so this is the Jacobian you have to find. Then use the surface integral that is given to you pi over dA. So that will be given, and we will change this f into Jacobian of uv divided by xy into du dv. Okay, into du dv. So I have written this previously. So check this. So you have to find the Jacobian, take its magnitude, then change phi to f, then take the magnitude, then du dv. So this is the Jacobian formula. Okay. Similarly, I have told you another the inverse Jacobian. This is the inverse one. That is the inverse Jacobian. Now this is nothing but xy divided by ub. So what will be that? That will be del x by del u into del x by del v, then your del y by del u, then your del y by del v. So this is another Jacobian, and remember j into j star equal to 1. So this one we don't need. We need this one. Then use this in the surface integral to find. So find the Jacobian. So first of all this. So this is the third case actually. This is the the third technique, and this is the third case also. First case is change the variable xy to uv. Second case use this formula that we have previously written, and this is the third case. How you will find the Jacobian? Actually this is the second one. You have to first find the Jacobian, then use this Jacobian, but use the positive Jacobian, then find out the surface integral. So these are the all three cases how you will find the entire for the vector field, and how you will find the Jacobian, then how to use this. So these are all about the surface integral. Okay, so do some problems that are available in the online also, then you will find the dx dy. Then the important thing is how you will find the surface integral. If suppose given to you x square y dy dx, then how you will find this 0 to 1, suppose 0 to 2, then how you will find this? Remember, the first one is the first, the second one is the second. These are the limit. So what is the limit of y? 0 to y 1, but 0 to x 1 in this case. Okay, so what we will do? These are constant, these are not variable. 0 constant, 2 constant, 0 constant, 1 constant. So what we will do? We will write to 0 to y, then this is the x term. Okay, so this will be x square dx. Then 0 to y, so 0 to 1 here. So who is the 0 to 1? 0 to 1 is y, so this will be y to y. So now you integrate this, multiply, you will get the answer. Okay, so this is one technique. So what is the another form? If this is x and this is x square, remember here y will not be there because here is y. Okay, if this is y, then this will be x. Since this is y, so that will be x. Then how you will solve this? Same technique, just to change x to x square. But remember, what is the important thing here? I have changed the 0, 1 to x square and the 0 to x. So this is x to x square. So the integration is x to x square, y to y. Remember, don't do this one first. Do this one first. Then in the step 1, don't disturb this. Okay, first do this one. First do this one. Then you solve this. Then what you will get? Now 0 to 2 x square. This is 1 by 2 y square, and the limit is x to x square into dx. Then that will be your answer. Remember, first solve the y, then go to x. Don't solve the x first. Then your answer will be in the x form. Then your answer will be your x term. That is wrong. So first do the integration with respect to y, then solve this, then do the integration with respect to x. So if there is constant, but there is not constant, here is x and here is x square. If there is constant, then you can solve any one, but there is no constant. These are the variables. Okay, so first do the dy, then solve this, then do the integration with respect to x. Okay, so another case will be also there. So another case will be also there. If this is x and this is y, if this is dx and this is y, then your x will be in terms of y and your x square will be in terms of square root of y, and this will change to 0 to 1, 0 to 1 or 0 to root 2, anything that will be given to you. So remember, here in this case your dx is first, dy is second. So what we will do, same technique also here will be applied. So what we will use, so what we will use, that first solve this one, this is a dx, so this is y, so this is y dy, and remember this is x square dx. So first solve this one, first solve this, okay, first solve this, then you will do this. Don't do this one first. First do the integration with respect to x, then solve this, then do the integration with respect to y. Okay, so this is all about your surface integral. So solve some problems that are available in the net also. If you are not able to do, then comment me in the comment section. We will solve the problems that you are getting trouble. Okay, so last one is your volume integral. So last one is the volume integral. So this is a 3D integral. So this is 3-dimensional. That can be your xyz or that can be your UVW. What is UVW? This is in curvilinear coordinate system. Okay, this is your curvilinear coordinate system, and this is your Cartesian. There are two types of integration always. So this is Cartesian and this is the UVW. So you have given a volume, that means the V can be as a cube, the V can be as a sphere, the V can be as a paraboloid. So these are all volume surfaces. These are the volume that is in the space. This is a 3D volume. So you have to do the integration. One function will be given to you, f of x, y, z, then your dv. So this is the notation. How the question will come, that is f of x, y, z, dv. So what is the dv? So dv can be dx, dy, dz, or dv can be dy, dz, ds, or dv can be dx, dz, dy. So in this case you will change. First dx come, then dy dz, or first dy come, then dx dz, or first dz come. So these are the 6 cases will become. And in the polar form, what is the curvilinear coordinate system? In the curvilinear coordinate system, your dv will be h1, h2, h3, du, dv, dw. Okay, so this is the dv. So this dv both are same. dx, dy, dz, h1, h2, h3, dv, dw, these all are same. But this is in the Cartesian coordinate system and this is in your curvilinear coordinate system. So h1, h2, h3 are the scale factors, UVW are the parameters of the coordinate system. Okay, so this is the volume integral. So similarly, one example I am giving to you, that is x square yz. Suppose I am telling you dx, dy, dz. So you can solve this using the curvilinear coordinate system. But if you want to solve in curvilinear coordinate system, then also you have to change this x, y, z to UVW. That is your r theta z or r theta phi. So okay, so this is given. If this is given you, so this is the x format. Okay, so first one is x, second one is u, y, and third one is your z. So how we will solve this? So the last one is the for last, and the second one is for second, and the first one is for second. So first, so there will be z dz integration y dy integration x square dx. Remember, here x is variable, so here we can write y plus z into y square. Here x already gone, only y, so this can be z square, and the last one is your constant. Okay, look, I have given you an example. Here z square. Okay, so this is z square. That is z square. So the first is x variable. So I have written first x variable. But when x variable, what are the other terms? So I have written this as yz. yz and this y plus z. The lower limit is y plus z and the upper limit is yz, because here x already gone and here since x already gone, so here y is coming, so what is the remaining? Z. So the limit will be z square. This cannot be the limit of x function, okay? This can be only the function of z, and the last one should be constant. Remember, the last one, the limit of last one should be constant, and the limit of the second one should be the function of z, and the limit of first one should be function of y and z. If this is in the format dx dy dz, if this is dz dx dy, then your variable also be changed, okay? So remember, this is the volume integral. Try to solve some problems. If you are facing any problem, then please tell me. We will take some problem class, okay? So last one is the theorems. What are the theorems of the vector integration? What are the theorems of the vector integration? So there are three theorems. So first we will see the Gauss divergence theorem. The Gauss divergence theorem. Okay, what is the Gauss divergence theorem? So the Gauss divergence theorem says that f vector dot ds vector equal to delta dot f into dv. So this is the volume V and this is S. Remember, V is the volume that encloses surface S. So remember, if this is the surface of a sphere, then that should be the surface of a volume. Or if you are taking the surface of a triangle, then this should be V. Okay, this should be S, this should be V. So V must contain a surface. That means B must encloses the surface S. Then we can apply this. And remember, the surface should be closed and the volume should be closed. If this is closed, then we can apply the Gauss divergence theorem. So these are the closed surfaces. Okay, remember, closed surface. So what we will write in the physical form? So remember, so this is the divergence. Okay, so this can also called as the flux also we can call. So this is the flux also. So what we will tell, now the surface integral of a vector field. The surface integral of a vector field over a surface S is equal to the volume integral of divergence of the vector field over the volume B that encloses S. So I am repeating. So what we will write the Gauss divergence theorem? The surface integral of a vector field over a surface S is equal to the volume integral of divergence of the vector field F over a volume B that encloses the surface S. So this is the transformation of surface integral to volume integral. Okay, so this is the transformation of surface integral to volume integral. So this is the first theorem of Gauss divergence theorem. Change the surface integral to volume integral. Okay, so now we'll go to the second theorem. What is the second theorem? The second theorem is the Stokes theorem. Stokes theorem. What is the theorem? The theorem is your line integral to surface integral. Okay, so we need see a path that enclosed by surface S. Okay, we need a path and we need a surface, but the surface should encloses the path. So what is the line integral of a C of a vector field is equal to the curl of that vector field into ds vector. Okay, so this is over a surface S. So remember, so what we will write, that the line integral of a vector field over a curve C, the line integral of a vector field over curve C is equal to the surface integral of curl of that vector field over a surface S that encloses the path C. Okay, I am repeating. The line integral of a vector field over a curve C is equal to the surface integral of curl of that vector field over a surface S that encloses the curve C. Okay, so this is the line integral to surface integral. So take the curl, then then find the n vector, then you will do the surface integral. Okay, so this is the Stokes theorem. Now last one is the Gauss divergence theorem. Sorry, Gauss divergence theorem we have already seen. So last one is your Green's theorem. Green's theorem. So what is Green's theorem? Now suppose a vector is given to you, that is m and n. Okay, what is mn? Now m is a function of xy and n is another function of xy. Suppose this vector field is given to you, and what is mn? Now m is a function of xy and n is a function of xy. Then your f dot dl, what will be f dot dl? So remember, this is a curve C. So what is f dot dl? Now this is nothing but m dx plus n dy. Remember to the dl and do the dot product over the path C. This is nothing but del n by del x minus del n by del y into dx dy. Okay, if this is plane integral. Okay, so this is plane integral. So this is the plane integral. So what is your n cap? That will be k cap for xy plane. Okay, and for xy plane your n cap will be k cap. For yz plane your n cap will be I cap, and for xz plane your n cap will be j cap. So this is the xy plane integration. If this is dy dz, then that will be del n by del z, and del m by del y, then dy dz. Okay, so this is the this one is the Green's theorem. So remember this. If this is the line integral to change the surface integral, but this is over a plane. Okay, so mn will be given to you, that is the function of xy, then do the partial derivative, then do the integration. Okay, so this is the Green's theorem. Then another thing I am telling to you about the application of the Gauss divergence theorem. So what are the applications? Remember the surface integral over psi del phi dot ds. Okay, so this is also a vector because del is your vector. So what will be this? So apply the Gauss divergence theorem. Apply the Gauss divergence theorem. F vector dot n cap. So this is your f vector. Okay, f vector dot n cap. So ये कितना होगा? ना delta dot psi into del phi over dv. So this is the volume integral. So for volume B, how we will do the operation? Del dot psi del phi. So that will be your del of psi dot del upon phi plus psi del square phi into dv. So remember this formula. I am just taking it. Okay, correct. So del dot psi del phi, what is del of psi dot del of phi? These are vector quantity. So this is the one application of using the Gauss divergence theorem. So psi del phi equal to, this is the surface integral. So what is Gauss divergence theorem says? Change this to volume integral using the divergence. So take the divergence. So this is the formula, del dot psi delta phi. What is the formula for del dot psi del phi? Now del psi dot del phi plus psi del square phi into dv. Okay, so this is the application 1. This is one application. Then we will do the second application of the Gauss divergence theorem. So these are the formula of divergence and curl. So remember. Then what is the third one? So the third one is says that the surface integral of psi del phi minus phi del psi So these are the vectors. Okay, so these are vectors. This is vector, this is vector. So the surface integral will be over ds. So what will be this? And this will be your volume integral. Then I think side L square phi will be there. Okay, so this is your F vector. Okay, so this one is your vector. Then use the Gauss divergence theorem. So that will be del dot psi del phi minus phi del psi into dv. Okay, so if you will solve this, you will get psi del square phi minus phi del square psi upon dv. So this is the formula. If you will solve this, so try to solve this. Del dot psi del phi. Previously I told you how we will find del dot psi del phi, then how we will find del dot phi del psi, then subtract them, then you will get this volume integral. Okay, so this is one general application. So try to remember, try to make these notes in your application too. So these are all about your vector integration. If any problem to understand or if any mistake, then please comment me, and if you like the video, then please share it to your friends or relatives so that other students will get these notes. Okay, so if you have any mistake, then please comment, and also of course subscribe the channel and click the bell icon for the new video. Thank you. Jai Jagannath. So we'll stop here.